Welcome to our review on extracting aluminium. When we're talking about our aluminium ore, we usually refer to it as bauxite. So bauxite contains aluminium oxide. What we actually find is in order to extract the aluminium from its ore, we have to use the process of electrolysis. And the reason for this is if we think back to the reactivity series, then aluminium is more reactive than carbon, which means that by heating aluminium oxide with carbon, nothing would happen because the aluminium is more reactive. So we have to use electrolysis in this case, which means it is a more costly process. Hopefully, if we think back to the work we've done on electrolysis, one of the key points that you know is that we've got to have a liquid or a solution for the electricity to pass through. You can't just jab some graphite rods into a block of aluminium oxide and then it will somehow magically separate. Doesn't work. And this is where our first problem comes in, because aluminium oxide actually has a melting point of 2072 degrees Celsius, which is a little bit warm. So in order to actually heat up aluminium oxide to make it melt, that would be incredibly expensive. So it would add a ridiculous expense onto what is already an expensive process due to the electricity we then have to use to separate it. So to get around this, what we actually do is we dissolve the aluminium oxide in a substance called molten cryolite. And that means that we can then carry out electrolysis at the ever so cooler 950 degrees Celsius. If we now look at the setup for our aluminium electrolysis, then at the top I've given you the diagram of the electrolysis tank. So what we've actually got at the top, we've got our power supply, which is our positive coming in there. And you can see that's attached onto the carbon anodes. So these are just blocks of graphite that act as the anodes. As we then go down a little bit further, we've got that yellow stuff, which is our aluminium oxide dissolved in the molten cryolite. And the black lining there is actually a carbon lining of our cell, which is going to act as the cathode, the negative electrode. So we've got the blocks of graphite as the anodes, and then this carbon lining is going to be the cathode. And that then has insulation around the outside to try to keep as much heat in as possible to minimise any wastes there. If we then recall, when we're talking about these two different electrodes, one is positive, one is negative. So what we have is the cathode is the negative electrode. So I've given you the little picture of good old grumpy cat in the bottom corner there because, of course, very negative, and it's a cat. So negative cathode. Because the cathode is negative, it will attract positive ions. And aluminium, being a metal, makes positive ions. So we produce aluminium at the cathode. The anodes, which are the positive electrodes, they will attract the negative ions, which in this case is oxygen. So at the anode we produce oxygen, and it's actually going to react with the graphite that makes up the anode itself to make carbon dioxide. Hopefully at the end of this video you can now explain why electrolysis is used to extract some metals from their ores like aluminium, and you can describe the process of electrolysis to actually extract the aluminium from aluminium oxide.